This is a short revision lesson on second order linear differential equation. And here we will talk only about ordinary differential equation. So an equation of the form y double prime plus p of x times y prime plus q of x times y equal to f of x. Let's call that equation 1. So equation 1 is the standard form of second order linear differential equation which is non-homogeneous. And what we mean by non-homogeneous is when the right hand side, i.e. f of x, not equal to 0. So when f of x equal to 0, the equation is called homogeneous. Equation 1 is called homogeneous. So in this lesson, we will only deal with homogeneous first second order equation with constant coefficient. So we will also assume p of x and q of x are constants. And therefore, equation 1 will reduce to the following. So y double prime plus p times y prime plus q times y equal to 0. Equation 2 is a standard second order linear differential equation with constant coefficient. It is also homogeneous because, as you can see, the right hand side is equal to 0. Well, we will now explain or attempt a method of solution. In order to solve a second order linear differential equation with constant coefficient, we will use what we call a characteristic equation or auxiliary equation. Now, in this way, we will replace y double prime by lambda. We will also replace y double prime by lambda squared, and y prime by lambda. And y will be replaced by just lambda to the power 0, which is 1. So y replaced by 1. So this now gives us lambda squared plus p times lambda plus q equal to 0. As you can see now, equation 3 is a quadratic equation in lambda. And if we use the formula, standard form of a quadratic equation, to solve that, we will obtain lambda is equal minus p plus or minus square root of p squared minus 4 times a, which is 1, times c, which is q, over 2a, which is 2a. Now, this is the standard formula to solve a quadratic equation. As you know that any quadratic equation could either have real distinct roots, so two solutions, or real and equal roots, so just one root, or two complex conjugate roots. So I'm going to we will consider here three cases by mean of an example. So let's take now example number 1. Let's consider the differential equation y double prime minus 3y prime plus 2y equal to 0. Let's call that equation 5. Now, the corresponding characteristic or auxiliary equation, it will be lambda squared minus 3 lambda plus 2 equal to 0. Now, as you can see, this quadratic equation can be factorized, so we can rewrite that in terms of its factors. So lambda minus 2 into lambda minus 1 equal to 0. So this gives me two roots. So let's call them lambda 1 equal to 2 and lambda 2 equal to 1. So the general solution now for the differential equation, so the general solution for equation 3, or is it equation 5, sorry, is y equal to c1 e to the lambda 1x plus c2 e to the lambda 2x. Now, if we substitute the values of lambda, we will obtain that y equal to c1 e to the 2x plus c2 e to the x. And this is the general solution for equation 5.